Okay, welcome back. So we were looking at question 5, now we're up to question 6. So I love these embedded questions that have the chain rule in them. So this is much more representative of Maths 1. So I'm really encouraging you to come to terms with this, okay? This is really important that you do this. Now, again, it's gymnastics. It's really not calculus, okay? So if we do a bit of pre-work, in our pre-work, what we would do is prepare this function so that it can be directly differentiated. So 2 minus x squared to the power of a half. Okay, now the thing that we notice is that we can differentiate this one directly. We can put the minus 1 out the front, and minus 1 is minus 2. Okay, so that's great. We've got that first term there ironed out without too much problem. However, this now represents a chain rule. 2 minus x squared. And then we've got to write this thing in terms of u to the half, because we've done that. Now, because it's part of a term, I can't simply write y equals something. So I'm just going to let it sit there as u to the half. But I'm going to introduce another idea here. So here we're going to do Leibniz notation of du dx because we want that part of the chain rule. But over here, I'm going to say let's do d du. And let's put the equals here. d du of u to the half is a half u to the minus a half. This is minus 2x. So they are going together as a pair. Okay, so we're still going to get our dy dx part. Okay, now I'm actually going to phrase it this way. I'm going to say, let's just do d dx because we're doing a part. If we're doing the whole thing, see how we're doing a part? So we're still going to have our d dx. It's just that we're going to go through. Okay, so this is an important moment. So this is now equal to that common thing that we see a lot of, 1 over 2 root u times minus 2x. So that's going to sit on top. And was 2 minus x squared. The 2's will cancel. So we'll be left with minus x over the square root of 2 minus x squared. Okay, so that is our second part. So down here we can put plus, now it's a minus, so we're just going to put minus x over the square root of 2 minus x squared. But look at all the work that had to be done for the chain rule, okay? A chain rule in expression and equation form. Okay, see that? It's the same thing. It's just that the way we present the information. So let's have a look at that. So we're going to differentiate 1 over x. 1 over x. And then we're going to have square root of 2x squared or 2 minus x squared. Let's see what that looks like. Is it differentiating the same question? 1 over x plus square root of 2 minus. So we're pretty confident of that. And then what we've got here is minus 1x squared minus x over 2. So happy days. We got that, and we're happy to have that. Okay, that's a very good result. So we can do this checking to help us along. There's no problem with that. All right, so for part 7, we've got another, now we've got a chain rule within a chain rule, and this is very definitely going to turn up in Maths 1. I can tell you now, without any equivocation, this will be somewhere in an early test that you do. So here's probably a question from there, I don't know. So we've got a cube, then we've got a cube root of x minus x. So if we let u equal everything in the middle, minus x, I've exaggerated that, so I might just pull that back down. Okay, bring that over. Just letting you know that it's outside. Okay, then y would be equal to u3. So these are straightforward ones, but now this is a problem because we have to set this as x to the power 1/3 minus x. So we might get away with that. So it'll be 1/3 x, 1/3 minus 1. And this will be just minus 1 as a derivative. So 1/3 minus 1, it never goes away. Same family. So we've got 1/3 x to the minus 2/3, subtract 1, which is 1/3 the cube root of x squared minus 1. So that's this part here. This is 3u squared, which is equal to 3 squared, the cube root, minus x. That's the original. So we're going to put them together as a product to give us du dy dx. And so we'll get 3 the cube root of x cubed minus x all squared times 1 over 3 times the cube root of x squared minus 1. Now I'm liking that there, okay, but I'm conscious that this is not 1, so now it becomes algebraic gymnastics. The calculus is done, and it's getting a bit ridiculous, isn't it, when we do a chain rule like that? So let's do a cube root. Let's do all of that. So we want a cube root, please. Cube root. Of x minus x to the power 3. Put that there like that. Let's see what that looks like. It doesn't like cube root like that, Jason. Cube. But just CU. Getting it in my square root was s, so it might just be that. Oh, and the other thing I've done is I've put this in. Which probably needs that. Still doesn't like the cube root. There you go. Cube root. Okay, so when we get these, there's a step there somewhere where we have to call time and say, well, hang on a minute. How much do we want to make all of this? Okay. So if you can clearly see the answer's got the cube root of x squared as its denominator. So we would need to do that by multiplying through by everything. 3 cube root, so that's our new form of 1, bit of an odd form of 1, but nevertheless it's there, times 3 times the cube root of x. So that's that one. So that's now the same family. And the cube root. And 1 is going to get painted up as 3 the square root of, there you go. So now we can clearly see that they're all in the same family. So we only need to have the denominator as the same family. And the numerator is going to be product of these things. Well, that's a square, so that's not going to go anywhere. So there'll be a product. So these are common factors now. That's a common factor. That's a common factor. So we can pull that out. Okay, so that kind of explains that bit. So we're going to end up with, I think that's fine, across that minus sign we had 3x. I think I made a mistake here. This is, so I put 1 in that form, so we get 1 minus that. I think that's where I've left that off. So I think I have to acknowledge that's a 1, but if that's a 1, it doesn't matter. I think we're okay. All right, so this is what happens. This is exactly what happens. So once you start going a bit further in with your gymnastics, you start to get these problems. So I don't want this subject to be about that. I want you to explore that for fun's sake. Okay, I want that to be something you do for fun, not part of your progression in the degree that you're doing or in this particular area of study. So that's a reality that we have to deal with, that we can do this, but once we get to there, we have actually answered the question. Okay, the next step in terms of simplifying is getting these denominators the same. So if I do 3, I'm just going to spend a little bit of time doing this. X squared over times 3 No, that's not right. I don't need to do that because that's a square. See, there's a simple thing there. I don't need to do that because I'm seeing it as a group. I'm seeing it as more than that. I'm seeing it as the wrong group. So I better just do that. That's more like it because they're already there. They're already there as. So that's my mistake. Sometimes algebra requires this. they'll cancel straight off. And then we've got a minus 1. Now that 1 can be made up of 3. That makes more sense, doesn't it? Cube root of x squared over 3 lots of the cube root of x squared. So now we're talking, we've got the same family. That's just 1 now times that. So we've got the same family on the denominator. Cube root of x, 3 times the cube root of x squared. And then up here we've got I think that's a simple version of it. Okay, so sometimes you can spend a lot of different times. So if I'm going to set an algebraic question, I'm going to be very specific about what the output is. That's something that we can be assured of. Alright, so the next thing I wanted to do, I'm going to come back and make a last video just to cover this last topic, which is still the chain rule. It's just using some tricks. So we'll come back and do some trig chain rule in a moment. So I'll just put that across. I want to see a bit more of that one, a bit less of that one. Back soon.